Did you know that China is building some of the largest and most complex bridges in the world at record speed? With revolutionary engineering techniques and an incredible ability to overcome natural challenges, the country is redefining the limits of civil construction. Get ready to discover how these megastructures are transforming the global landscape. China, with an impressive territorial area of 9.5 million square kilometers, is the second most populous country in the world, home to approximately 1.4 billion inhabitants, second only to India. Located in East Asia, the nation boasts vast geographical diversity, with deserts, lakes, rivers, and mountains. Since 1978, when it adopted a mixed economy under the leadership of Deng Xiaoping, the country has undergone an unprecedented economic transformation, achieving the status of the world's fastest-growing economy over the past few decades. Today, China holds the position of the second-largest global economy, reflecting its enormous influence on the international stage. In terms of transportation, the People's Republic of China stands out with its extensive infrastructure, boasting the largest railway network in the world, as well as a modern metro and air transport system. But what has truly captured the attention of experts worldwide are its impressive water-based constructions. These works, especially its bridges, are being completed with extreme speed and precision, leaving many to wonder, how does China manage to build aquatic bridges in record time? In this video, we will explore the extraordinary technology employed by China in building aquatic bridges and how it has defied global expectations in terms of engineering and innovation. I'm Luciano Guimarães, and I invite you to closely follow this fascinating topic. China is, without a doubt, a global reference when it comes to bridge construction. Many of the most complex and ambitious bridges ever built worldwide were erected by the Asian powerhouse, often in record time, astonishing even specialists. The world has much to learn from China, especially regarding its advanced techniques, cutting-edge equipment, and other secrets behind these constructions. But before diving into the specifics of Chinese bridges, let's first understand the traditional methods of aquatic bridge construction used around the world. Building a bridge over a valley or gorge can be relatively simple compared to spanning bodies of water. This is because when crossing water, the bridge's foundation must be submerged, adding an additional level of complexity. To ensure the structure's stability, it's crucial to properly anchor the foundation to the ocean, river, or lake bed to prevent the bridge from being compromised by currents. Four main methods of underwater construction have been used globally, each adapted to different conditions and types of bridges. The first technique, known as caissons, involves using large hollow structures that are lowered to the ocean or river floor. These structures are then drained of water, allowing workers to dig until they reach solid bedrock. Once this point is reached, the caisson is filled with concrete, becoming part of the bridge's solid foundation. Another common method is the cofferdam, a temporary structure built in the water to isolate the work area. It acts as a dam, diverting water and creating a dry environment where the bridge's foundation can be built more easily. The third technique involves using driven piles, which are metal or concrete tubes driven into the underwater bedrock. These tubes are later filled with concrete, creating an extremely sturdy foundation. Finally, we have the sinking of structures method, where the bridge foundation is built on land and then sunk into the desired location, anchored to the waterbed. Building bridges with submerged foundations is no easy task. There are numerous challenges that must be overcome to ensure these structures are safe and durable. Let's highlight three of the main obstacles engineers face. The first challenge is finding materials suitable to withstand underwater conditions. Many materials used on land are not appropriate for aquatic environments, where constant exposure to water can corrode them and compromise the bridge's integrity. The second challenge is dealing with water pressure. Submerged structures must be designed to withstand not only the weight of the bridge but also the immense pressure exerted by the water, both during construction and throughout the bridge's lifespan. The third major challenge is corrosion. Water, especially salt water, can quickly corrode materials, reducing the bridge's lifespan and requiring constant maintenance. China has overcome these challenges through impressive technological innovations. In the past, bridges had relatively small spans, making construction easier. However, as the country expanded its infrastructure and maritime traffic increased, the need arose to build bridges with larger spans. This presented new technical obstacles, as the larger the span, the more difficult and expensive the project becomes. To overcome this problem, Chinese engineers innovated by using multiple continuous spans in their bridges. This method allows for covering large navigable areas without compromising safety or drastically increasing construction costs. A remarkable example of this innovation is the Taishan River Bridge, the world's first suspension bridge with 2 bridge spans and 3 towers. With an impressive central span, this bridge was designed to facilitate both road and maritime traffic. Instead of using a single central tower, As is common in large-span bridges, Chinese engineers opted to use two large towers, significantly reducing construction costs and improving the project's efficiency. Another innovation widely used in China is the three-cable plane structure, designed to support multiple forms of traffic, such as high-speed railways, subways and expressways, all on a single bridge. This not only reduces the number of bridges needed but also makes traffic more efficient and the structures more robust. One of the most interesting innovations developed by China is the use of rotating construction techniques. Instead of assembling bridges directly over the water, engineers build large sections of the bridge on solid ground, taking advantage of the riverbanks. These sections are then rotated and moved into the desired location, where they are positioned and secured. This not only speeds up the construction process but also minimizes environmental impact and reduces risk to workers. Another technological advancement is the assembly of prefabricated bridges. The ability to produce entire bridge sections in factories and then transport them to the construction site has been a game-changer. The prefabricated beams used in Chinese bridges can withstand immense loads, and the on-site assembly process is extremely fast and efficient. This allows China to build long bridges that span the sea in record time. One of the greatest symbols of Chinese efficiency in bridge construction is the SLJ 900 machine, also known as the Bridge Segment Launcher. With an innovative design, this machine is 90 meters long and weighs 580 tons, capable of reducing bridge construction time by up to 60%. By using the SLJ 900, a construction process that would normally take years can be completed in a matter of months. This machine moves along the bridge, positions the prefabricated sections, and fits them with millimeter precision, revolutionizing the way bridges are built around the world. In addition to technological innovations, politics also plays a crucial role in China's ability to build bridges in record time. Under the leadership of the Chinese Communist Party, the government takes a centralized and unified approach, which allows large-scale projects to be executed without the lengthy bureaucratic approvals common in other countries. This significantly accelerates the construction process, ensuring that projects are completed quickly and efficiently. China has stood out globally for its ability to construct aquatic bridges rapidly and efficiently. Combining technological innovations such as the use of multiple continuous spans, three-cable plane structures, rotating construction techniques, and the use of the SLJ 900, China continues to redefine the boundaries of engineering. Furthermore, the country's centralized political approach ensures that large infrastructure projects are executed without delays. However, China's future still faces challenges, such as the zero-COVID-19 policies, which could impact the economy and the country's ability to continue growing at such a fast pace.